Okay, this is the P3 paper from October 2021. If we have a look at it, we can see that this is an integration question. We're going to be using the reverse chain rule. Let's just remind ourselves, we're looking for, if we have a situation where we have f-x over fx for any fractions, that's just straight away log fx. Or the other thing that we might be looking for is the integral of f-x where we have g fx. Now what I'll do is I'll leave that one there because I think we have actually got this second one, and I'll explain it more using the actual example that we've got here when we're doing it. So if we look at part one says, can we find the integral between 4 and 2 of 8 over 2x minus 3 cubed dx. And the first thing to notice is this not f-x over fx. If it was f-x over fx, the differential of this thing would be in the numerator. Well, because of that cubed, the differential of 2x minus 3 all cubed is complicated. It's 3 lots of 2x minus 3 squared times 2 there. That's certainly not what we've got in the top one. So because it's not f-x over fx, the way to look at this then is to rewrite this out as being 4 and 2, 8 lots of 2x minus 3 to the minus 3 dx. And now we've got it in this format. Now we've got it in this format where what we're saying is, look at this function. What's the derivative of that function, which is 2? Well, 8 is, we're not interested in multiples, so yeah, 8 is the right format to be the differential there. And what I've got here is I haven't just got fx, I've got some function of fx. It's normally actually fx to the power of something, which is what we've got here. So as soon as we recognize it as being this type, which it is, we then say, right, okay, if that's what I've got, what I'm going to do is I'm going to guess what I started out with as my function, that when I differentiated it, it ended up looking like that. Now, the only way to end up with minus 3 after differentiating is to start with minus 2. So I know this is the right method. This isn't a guess now. I know this is the right method. I'm going to get an answer here. I'm going to get something down here. And then what that'll do is that will look close enough to this thing that I can just make some sort of adjustment because of multiples. We'll talk about that when we get there. So I know this is the right method. I'm going to actually differentiate that. What is the differential of y equals 2x minus 3 to the minus 2? Right, so go through the process. Multiply by the power. Take one off the power. Multiplied by the differential of what's in there. So multiplied by 2, which now means that the differential of what we had there, 2x minus 3 to the minus 2, is minus 4 2x minus 3 to the minus 3. But what that's giving me is this, that the integral of that works out to be 2x minus 3. So the integral of minus 4 2x minus 3 to the minus 3 works out to be 2x minus 3 to the minus 2. Well, I haven't got that at my start. I've got 8 lots, not minus 4 lots. So all that means is that when I'm doing my integral now, the integral of 8 over 2x minus 3 to the 3 dx is just equal to minus 2 lots of 2x minus 3 to the minus 2. So we've made that adjustment because of the multiple there. And now all we need to do is to go ahead and finish off the question putting the values in. So if we then do that, Take your time over this. So it's minus 2. If I'm sticking 4 in, I'm going to get 8 minus 3 to the minus 2. So it's that minus, if I stick 2 in, I'm going to get minus 2, 4 minus 3 to the minus 2 here. And so just take your time with it. The first one will become, put it into the calculator, no problem with putting it into the calculator. This is minus 2 over 25, but then it's plus the minus and the minus there. Cancelling each other out gives us that, which gives me my final answer of being 48 over 25. Let's just go back. It just says the exact value, so that is an exact value. A fraction is just an exact value straight away. So that's part A done. Let's have a look at, or rather is it A part 1 done. Let's do A part 2, which says find in its simplest form the integral of x squared plus 3 to the 7 dx. Let me just bring this bit down here again now. And we can see that we've got exactly the same idea again. So I've got some function in here. This is my little fx. If you differentiate that, differential of x squared plus 3 is 2x. Having x is the right form. It just needs to be a multiple of it. So yeah, I've got something here where I've got a function here. I've got the differential outside. And as I said to you just a moment ago, when we say g fx, we mean some sort of function of, in this case, x squared plus 3. And quite often it is fx all to the power of n here. So if we're looking at this one then, as soon as I see it's that format, that gives me the license to say, right, I'm going to, just like I did with the last one, I'm going to guess what I must have started off with as my y, that when I differentiate ends up with this business here. Well, the only possibility here is x squared plus 3 to the 8. I say this is a guess. It's not really a guess. I know this is going to be right. If I go through now and do the differential using the chain rule, treat it as something to the power of 8. So that's 8 lots of something to the power of 7 multiplied by the differential of what's in there, which is 2x. Right, yeah, this gives me 16x. X squared plus 3 to the 7. And as I say, just like the last one, what this now tells me is that the integral of 16x, x squared plus 3 to the 7, will give me x squared plus 3 to the 8. I haven't got that. I've got a 16th of that, so it's going to be a 16th in my answer. So I can go straight away now to saying if I want the integral of x squared plus 3 to the 7 dx, that's going to be a 16th of x squared plus 3 to the 8 plus a constant. I'll just quickly, you don't need to do this, but let's do it in red. But if you wanted to just check now, if you actually started off with the 16th x squared plus 3 to the 8 and you differentiated that, we would then get, well, if we differentiate it, it becomes 8 over 16 x squared plus 3 to the 7 multiplied by the differential of x squared, which gives me 2x, which that does give me 16x over 16 x squared plus 3 to the 7, which gives me x squared plus 3 to the 7. I am not advocating that you do that at any step. We haven't got time in an exam to do that. It's just because I've got the chance to prove that to you here. But don't waste your time with that in the exam. As soon as we see it in this format, that gives me, that's how I get started, and this will automatically work out. Otherwise, I wouldn't be able to use the reverse chain rule. So that's how you do that question. Right, reverse chain rule. Hopefully that makes sense.